process to workflow alignment. My name is Knut Dinkelmann. I'm from the University of Applied Sciences and Arts Northwestern Switzerland. I'm a member of the project team of the CloudSocket. Please, as for convenience of everybody, please mute all your microphones. If you have any questions, you can type your questions into the chat window, and we will then in the end have the possibility to answer the question and discuss them. Okay, this is the agenda of the webinar. First, there is a short introduction into the CloudSocket project. Then I will talk about modeling and semantic lifting of the models, deal with requirements modeling, and then talk about how to align business and IT in the cloud. So this is an idea of the CloudSocket projects. The idea is to bring whole business processes into a cloud, not only single applications or services, but whole business processes. So to bring processes into the cloud, first we have to have the requirements from the business. On the other hand, we have different cloud offers from one or several cloud providers, and the role of the alignment is to connect the business and the cloud. So we have to satisfy the business requirements with the services that we find into one or several cloud providers. To do this alignment, we have to define the requirements. This shall be done by describing the business processes, which is the process flow, but also the context of the business processes. And we need a description of the cloud offerings, so the description of the specification of the services that we can use. This is a highlight of part of the CloudSocket architecture. Here you see in the background the whole architecture. Our focus is on this alignment, which consists on the one hand side of the modeling part. So we need to model the business processes from the business perspective, which are called here the business episodes, which are the requirements for the services, requirements for service level agreements, and maybe also requirements for the billing. And on the other hand side, we have a model of the workflows, the different offers that we have from the different cloud providers. We have maybe some rules and key performance indicators that have to be satisfied by the cloud offers. And then we have the alignment part, which is here in red. So we analyze the business process requirements. We identify the workflows or services that might satisfy the business requirements. And then we create a design package for business process as a service. So this is the general idea. And the point is mainly to map the service requirements, which should be described in a business language so that the business user are able to describe them, and they are mapped to the workflow descriptions, which are more described in a technical language as they come from the technical providers. So on the one hand side, we have to map the requirements to the descriptions, and on the second, we also have to translate the business language to the technical language. Now, the first focus is how can we do this modeling? So a main idea is that on the one hand side, we have the models in a graphical way. So we model the business processes, we model the workflows, and there can be one or more workflows that can be used to realize the business processes. So this is a graphical way. This is typically understandable by human users, but to do the alignment, we need some kind of formal representation. In our approach, we use an ontology as the formal representation, and we map the elements of the models, the graphical models, to classes in the ontology. And this mapping is what we call the semantic lifting. So we have the semantics description, a meaning of the elements that we have in the process and in the workflow models. And this is now the general architecture, more detailed, what I just said before. Here we have the typical modeling environment. This is based on the ADOxx modeling environment. So we have the meta models defining the modeling elements, and based on these meta models we can define the models. And now here on the right we have the formal representation. So we have an ontology where we define classes, where we define rules, and we have an inference engine that can work on the graphical representation. So the left part is for the human interpretation. It's a more informal or semi-formal representation, and the right part is a machine interpretable representation which is formal and which can be executed. But these two are not strictly separated. There is a mapping between the two. On the one hand side we have an ontology which gives a meaning to the elements of the meta model. Then we can use the ontology to semantically annotate the graphical models so that the elements in the models and also the attributes have a meaning as defined in the ontology. And then we can translate the models in formal representation which are represented in a triple store, and this is the basis and the input for the alignment component, the inference engine. I will go through these different parts of this modeling environment. First we look at the graphical representation, the BPAS modeling environment. So this is what we typically have. We have a business process model. In our approach we use BPMN as the modeling language. We have the pool, we have the lanes with the participants of the process, we have sub-processes and tasks, and we have data objects that can be used. In this example we have a process for a multi-channel campaigning. So we have a sub-process to provide the campaigns, and then we have several kinds of campaign which are the second sub-process, and when a campaign has been done, we can decide whether we want to continue or whether we want to quit the campaign. So very simple process. In the first we have a more user part to provide the content for the campaigning, and then we have the part for the execution of the campaigning in the social media. So this is the typical model, and now we want to show how we can give meaning to the elements of the model. And this is done by our ontology. What we have is the BPAS ontology, Business Process as a Service. This ontology is based on a standard called Archimeo, which itself is based on an enterprise architecture standard Archimate from the Open Group. So we translated the elements of Archimate into an ontology, having the classes, and now we extended these classes with aspects that we need for Business Process as a Service. In addition, we included some other ontologies, for example, to describe the functionality of processes and to describe non-functional requirements. Okay, and this is how the ontology looks like in the tool. On the left, we see elements of the enterprise ontology, the BPAS ontology. So, for example, with the Archi name tag, this means that these are aspects and elements that come from Archimate, and then we have elements from BPMN, and they are integrated with the Archimate elements. So we see here the sub-process or a task are a special kind of business activity, and the business activity is a behavior element of Archimate. So we can define the meaning of the model elements with the ontology. On the top right corner we see a top-level ontology, because we also need some aspects like time and location, and these are also defined in the ontology. We included them from already existing top-level ontology. So this gives the meaning of the elements that we have in our modeling environment. And now we can also extend the models that we have with additional semantic descriptions. So we have the human interpreter models, and we enrich them with the semantics, and the semantics again comes from the ontology. To do this, we have the models, and if we, for example, want to add a value for an attribute in the description of a task, then we can call a web service. The web service looks in the ontology for possible values that we can add to this attribute, and then this value is presented to the modeler, and the modeler can select the appropriate value. And when we then have the model with the modeling extensions, then we have the translation step. So we export the content of the model, transform them, and import them in the triple store. And this gives us then the possibility to do the alignment. So we have a formal representation of the graphical elements plus the extensions that we defined in the ontology, and have the input for the alignment component then. So to define the requirements and to allow the alignment, we have to have a formal description of the business requirements on the one hand side, and the description of the workflows that we use for the implementation of the processes on the other hand side. And this is what I want to show now. How can we represent the requirements and the workflow descriptions? Here we see again our process model that I already showed before. And now we want to assign requirements that we have from the business perspective. So what we do, we can group the different tasks and activities of the process, and for such a group we can specify the requirements, the process requirements. Process requirements is a new modeling element, and the modeling element has several attributes that we can fill to define the requirements. I will come to the possible attributes later, but the meaning of the attributes are again defined in the ontology. So here we see that the business process requirement is also an element of the ontology. So the business process requirement again has a meaning. And we do it similar with the workflow description. This is now an example of a workflow. For the workflow we use again BPMN to model the flow, but now the tasks do not stand for business activities, they are standing for potential services that we can use to implement a process. So the workflow is the automation of a business process. And now we say that the workflow description is for such a lane. A lane is an actor, and the actor can either be a human actor or it can be a service. So for each of the actors, this means for every lane in the workflow model, we define the workflow description. They correspond to the requirements. The requirements say what do we need, and the workflow descriptions is what the workflow or the services can offer, so that we can later make a mapping between the descriptions and the requirements. The workflow description again are defined via attributes that are specified in the notebook, and also the workflow description is defined in the ontology. So again, we have the graphical representation with the attributes, and we have the meaning defined in the ontology. And these are the typical categories of requirements and workflow descriptions. So we have functional requirements, we have requirements related to data security, we have performance requirements, we have requirements regarding the support that we expect from the service provider, and we have requirements regarding the payment. And the same categories are therefore the workflow descriptions. So we describe the functionality of a workflow, we describe security aspects, performance aspects, services that are support that is aligned with the services, and payment methods that are accepted by the provider of the workflow. And this is an example of such a notebook for the business requirements, and here we see the performance aspect, and this is written in a more business language. It should be able for a business user to specify the requirements. Here we say for the availability, for example, it can be specified in downtime in minutes per month that can be accepted. So the downtime should not be more than 500 minutes per month. This is what we have in this example. And we can also specify capacity that is needed for the storage. In this case, we specify it not in gigabyte or something like that, but we specify what are the information or the data that we want to store. In this example, we want to store videos, and we have 500 process executions per year and 10 simultaneous users, and from this we can calculate later the data storage capacity that is needed. And the third, here we have the response time, where the time level is regarded as low. So this is a possibility to specify the requirements from a business perspective. And this is the corresponding part for the workflow description. We see that we have the same things, availability, capacity, and response time, but they are represented in a different way. So here the availability is given in a percentage, so it's 99.6%. The capacity is given in data storage in gigabyte per month, and also the simultaneous connections are specified as a number. So what we later would have to do, we have to map the requirements in the business language to the descriptions given here in a more technical language. To give the values for this annotation, I use here again the business process requirement. For example, we specified that we want to store videos. So it's not that this is a text field where we have to type the different data elements that we want to store, but we can select the media type from the ontology. You would click the button Set Media Type. This would call the web service. Now the web service looks up the different media types that are available in the ontology, and then we can select the appropriate media type that we want to store. In this case, it was selected the video MP4, and this was added as a value in the attribute. So now also the attribute value has a meaning which is defined in the ontology. So these were for the non-functional requirements. We also want to specify the functional requirements. So this means what is the functionality that a service should offer. So we define this functionality of the process, tasks, and the sub-processes. For this we used a classification scheme which comes from APQC. And this is has different levels of process descriptions. And here, for example, we say that for the first sub-process it is 3.342, develop marketing messages, and for the other group it is 3.345, execute promotional activities. In addition to this APQC classification, we also want to specify semantics in the sense of object and action. This is derived from the naming convention for process tasks, where we say we have an action which is a verb and we have an object which is a noun. So for example, we can say we want to upload a text, or we upload an image, or we publish in Facebook, or we publish in Twitter. So we always have an object and an action. These are the two elements that we can use for the functional requirements or the functional description. Well, the problem now is that typically we do not have in mind all the possible elements of the APQC classification and all the possible actions and objects. And here again we give support. First, a short introduction in the process classification framework from the APQC. It consists of 13 process categories. These are shown here. You see that process category 3 is market and sell products and services. And these process categories can be specified in more detail up to 5 levels. Here we see that in 3.0 we have 5 subcategories. 3.3 is develop and manage marketing plans, and then we can further refine them up to 5 levels. So what we now do when we want to add the value to the requirement specification, we would go into the ontology, which we have here, and then go down to the ontology, and the possible values can be selected from the values that are defined in the APQC ontology. So the user does not have to remember the different categories, but can always look them up in the ontology. And also for the object and actions, we have ontologies. We have ontology for different objects. We have different actions, and we can select as a user the possible actions and objects from the ontology, and the system also takes care that only objects and actions are combined that make sense to each other. So we can upload a text, we can upload an image, but it would not make sense to upload some physical element. Okay, now we have the model with all the requirements, and we have the workflow descriptions, and now we come to the alignment itself. The alignment is on the lower left in the inference engine, has as input the triple store, the representation, the formal representation of the models, requirements and descriptions, and now makes the mapping between requirements and descriptions. This is what we show here. So we collect the requirements from the business processes and the workflow descriptions, and then we make a mapping between the two. So we look at the corresponding attributes, in this example here the availability, and we compare the availability that is defined as a requirement with the availability that is described in the workflow description. To do this, we have a two-step approach. The first is that we have to map the business language to the technical language. Remember that we have different ways to represent the availability in the requirements and the description part. So we map the two languages into a common language, and then we compare the two values from the requirements and the workflow description. And as a result, we will identify only those workflows that satisfy the business process requirements. So here's an example for the availability. So assume we have two processes with two process requirements, which specifies the maximum downtime. So one has downtime of maximum 12 hours per month, and the other one has the downtime of maximum 2 minutes per month. On the other hand side, we have a repository with 3 workflows and workflow descriptions. So we have workflow 1, which uses Jira and Zapier, the same also for workflow 2 and 3, and we have the different availabilities now given in percentage. So what we now do, we look at the requirements in the business process and compare it with the requirements that we have, with the description that we have for the workflow. And also for the second requirement, for the second group, we compare it also to the corresponding services in the workflow. And this is a rule that makes the matching. So we have rules to lift the values from the requirements to the workflow descriptions. So we check for the requirements, we collect the downtime, and then we make the recalculation so that from the downtime per month we can calculate the value in percentage. So in the end we will have a percentage, in this example, for 99.9%. And with this value we now look for the workflow definitions and workflow descriptions, and we say like those workflows that match the requirements. In this example, only the last workflow matches the requirements of both business process requirements, and only all the 3 workflows matches the requirements of the second part, business process requirements too. Because if you look that the workflow descriptions have availability for BPR2 of 99.9% and 99.98% and 99.97%, which is always higher than the 99.9% that we have as the requirement. While for the business process requirement 1, this is not satisfied because the first 2 workflows have availability which is lower than 99.9%. So we only have one workflow that can satisfy these requirements. And then can also look at the second example. This is the storage capacity. Here we have as a requirement that we want to store videos, and we have 5 process executions for storing the videos. And then the capacity of the workflow descriptions, we have the capacity given in megabytes, 2 workflows with 250 megabyte and 1 workflow with 1 gigabyte. Again, we make the mapping, we calculate the storage requirements for the videos. We can say we have 50 videos. Each video has 10 megabyte. This is a value that we get from the ontology. And we see that the requirements that we have would be 500 megabyte. Now we translated the value from the requirements to the value of the workflow description. And then we can make, again, a matching between the business process and the workflow. And we see that only the last workflow matches both requirements, and only all three of them workflow match only the requirement 2. So in the end, we can only use one workflow as the one that satisfies the requirements of the business process. So this was an overview of how we do the business IT alignment in the CloudSocket. The system is already modeled and realized as a first prototype, which can be also looked at in the development space of ADOxx. Here on this slide, you can see also the link, the direct link to the developer space. You can also find it from the CloudSocket website and have a link to this development space. Okay, this was the presentation, and I think we now have also time for some questions. Let's check whether we have some questions here. Are there any questions? So you can type them in the chat. Thank you. So I don't see any further questions. Okay, then thank you very much. I think then we can close the web